Hello and welcome to another video tutorial about FreeCAD. In this video tutorial we are going to model this fog bearing as it is shown here on the screen. We will talk about filleting edges and problems we could face with such operations. We will talk about reusing sketches in the part design module, and we will talk about different types of modeling strategies, and we will learn a new trick about doing revolutions in part design. The version we are using here is a 0.14 stable release for Windows 7 64-bit. So the first thing is, if you look at the 3D model here, you will notice that it has two basic planes of symmetry which we will use for easier modeling. The next thing you will notice is that if you would try to do a 3D model with, let's say, a cylinder with the outer dimension here, and then try to apply a fillet or a chamfer to this edge, you would run into a problem, because FreeCAD would tell you that if you try to apply this chamfer to this edge, there would be no material for the cylinder left. So what we can do now is to use a small trick to make the chamfer a little bit less than the applied dimension. This would be cheating. We will want to have a real 3D model, so we will try to use a different modeling approach. As you already have seen from the part workbench, you can use an approach that you model different parts of the 3D model and then do a Boolean fusion on all the parts to fuse them all together to one single 3D model. This is the approach we will use in this lesson here. So to be more precise, if you take a look here, the modeling strategy will be to model the base pad here, the next pad here, and then model also as pads these kind of ribs here. We will also then model as revolutions this part here, this part here, this here, this here, and this part here. Then we will do a multi-fusion, and then we will do pockets to get the holes in the 3D model, and then we will do a filleting of these four edges, and then the model is finished. Okay, so let's start with today's lesson. First I will close the document here. I will open a new document, and I will make sure that I'm in the part design workbench. I will start a sketch on an XY plane, and first I will draw a single vertical line here on the left side. Then I will use the polyline tool to create a vertical and horizontal line here in the upper right corner. I will close the polyline tool with a right click, and I will do the same operation here in the lower right corner. Now I will close the polyline tool again with a right click. Okay, so the next thing is to draw the arcs. Make sure that the midpoint of the arc is on the green axis. It is the y-axis in this case. We will make sure to catch this point here on the right side, and we will also make sure to catch this point here. if you do not catch the points, you can constrain them by selecting both points and applying a coincident constraint to these 2 points. So let's draw the second arc. We will catch this point here. We will catch this point here. And let's do the third arc. Okay, so now we are finished. And we also have a closed contour. So now I will select the vertical line here. I will press down Control on Windows and select this arc. And then I will apply tangency as constraining to these 2 elements. I will repeat the operation here. I will repeat the operation here. I will apply a tangency constraint here. And I will apply a tangency constraint here. Do not apply a tangency constraint here, as this would over-constrain the whole contour. It will not result in an error message instantly, but later on you will face problems. Since the whole contour is symmetrical to the horizontal axis here, the x-axis, I will apply an equality constraint to these 2 lines, and I will apply an equality constraint also to these 2 lines. As you can see, we have 4 degrees of freedom left, so now we will begin using dimensional constraints. I will apply a vertical dimension to the midpoint of these 2 arcs of 140 millimeters. Let's zoom out a little bit. And now I will apply a constraint of 25 millimeters radius to this radius here. I will apply also a radius constraint of 25 millimeters to this radius here. And the last constraint we have to set is, for example, a horizontal dimension between the origin and the midpoint of this arc. We choose horizontal dimension and we choose a dimension of 75 millimeters. Remember that if you did something wrong with the dimensioning, just double-clicking on the required dimension and entering a new value will update this dimensional constraint. So now we have a fully constrained sketch. Not every sketch needs to be fully constrained, but in most cases it is better to have fully constrained sketches. We will close the sketch and we will pad the sketch. Now I can show you something hopefully new. FreeCAD will also do small calculations in value fields. This means if I type, for example, now for the pad length to be 17 minus 2,5 millimeters and press OK, FreeCAD will accept the value and correct it to be the correct result of this calculation, in this case 14.5 millimeters. So now we made the first basic pad, and this is the first step of our 3D modeling exercise. Now for the next step, I will toggle the visibility of this first pad here, and I will create a new sketch, in this case on the YZ plane. So I will choose the polyline tool. I will try to catch the horizontal axis as starting point. I will create a vertical line, a horizontal line, Now back here to a vertical line, a horizontal line. Now vertical one, horizontal one. And let's go back to the axis here. And let's go back to the first point here. Of course, we have now over constraining, so we will delete this horizontal constraint. Now everything is fine again. So now I will apply a symmetry to these 2 points, and I will also apply a symmetry to these 2 points. And now I will apply equality to these 2 lines, so that these lines are collinear. So now we have to apply here a horizontal distance of 15 millimeters. We have to apply here a horizontal distance of 75 millimeters. So, and then we have to apply here a vertical distance of 70 millimeters. And now we have 1 degree of freedom left, which is this dimension here, and we will constrain this dimension to be 27 millimeters. And now that's it. We have a fully constrained sketch. We close the sketch. We will apply a pad operation, symmetric to plane, and we will set the length to be 40 millimeters. Now let's make the first pad visible again. Let's switch to axometric view and let's say fit all. Again, one of my tips for you is to apply keyboard shortcuts to all the necessary commands and memorize them or write them on a sheet of paper and put it beside your monitor and use them. You will speed up your working speed quite a lot with that. So we did now the first 2 pads, and now let's move on to the next modeling operations. Now the next modeling step is to hide again these 2 pads so that nothing obstructs our view, and to create a new sketch on the YZ plane. And now I use the polyline tool to draw a triangle here, and I use the polyline tool again to draw a triangle here. Now since I want these 2 triangles to be symmetrical in regard to the vertical axis, I apply symmetry constraints. Oops, I did omit vertical axis. Here we go. Now I use symmetry again, or I could also apply equality to these 2 lines. This would result in the same scenario. And now I could use also symmetry on, no, let's try again. Select the 2 points and the vertical axis and apply symmetry. That's it. We apply a horizontal dimension to this line of 12 millimeters. The vertical dimension of this line should be 35 millimeters. Now I move triangle a little upwards because I want this point to be in vertical distance in regard to the origin 14.5 millimeters. I use comma here, and now we have to apply to this point and the origin a horizontal dimension of 37.5 millimeters. Now that's it. We have a fully constrained sketch. We just close the sketch. We apply a pad operation of 10 millimeters length, and we tick symmetric to plane and choose OK. And if we toggle the visibility of these two pads again, change to axisymmetric view and say fit all. Oh, here we go. We just made those two ribs like they should be. Now we also toggle the visibility of these three pads, and we continue with the next pad by clicking on create new sketch, this time in the XZ plane. We apply OK, and we will create with a polyline tool in the upper right quadrant a sketch like this, consisting of a vertical line, horizontal line, now a little bit slope down here, and a horizontal line back. We will apply the constraints. First, we will set a horizontal constraint of 20 millimeter to this point. We will then also apply a vertical distance to this point. The vertical distance should be 14.5 millimeters. So the length, the horizontal length of this line should be 34 millimeters. The length here, the horizontal length, should be 6 millimeters. And we will apply a vertical distance of this point in regard to the origin. And the vertical distance should be 27 millimeters. We apply OK. We have a fully constrained sketch. We close the sketch. We will apply a pad operation of once more 10 millimeters. Symmetric to plane should be ticked, and we apply OK. Now we will toggle the visibility of the pads again to make sure that everything is OK. And as we can see, everything looks like we want it to be. Okay, since you can do revolution in part design with only one closed contour at a time, we will toggle the visibility of these pads and begin with the first revolution. We will create a new sketch, this time in the YZ plane. We apply OK. We will use a polyline tool to do a horizontal line here, vertical line here, a chamfer here, horizontal line here, chamfer back, and then back to the first point with a horizontal line here. Okay, so now we apply equality to these two chamfers, and we apply equality to these two vertical lines. We then apply a horizontal dimension constraint to this line. We will use 20 millimeters as a horizontal dimension. We will apply also to one of the chamfers a horizontal distance of 2,5 millimeters, and we will also apply to the same chamfer a vertical distance of 2,5 millimeters, and then we will apply a vertical distance to these 2 points, and we will use 20 millimeters as vertical distance. Now, if I close this sketch and try to do a revolution, I could use the vertical sketch axis as revolution axis, and I could use the horizontal sketch axis. But both cases are not the cases I like to have, because I want to have an axis which is parallel to the horizontal sketch axis, but it is not identical with the horizontal sketch axis. It has a certain distance to it. So in this case, I cancel the operation and I say edit sketch once more, and I use a third option. I will sketch a line. I will catch this point here, and I will catch the axis here, and I will apply a horizontal constraint, if not automatically applied to the line. And then I will toggle the construction mode of this line. I will select it, and I will apply toggle construction mode. Then I will apply a vertical distance constraint here. The vertical distance constraint should be 70 millimeters. We will zoom in here, and I will apply a horizontal dimension constraint to this line here of 20 millimeters. That's it. Now we have a fully constrained sketch. I close the sketch and I will try revolution once more. So as you can see now, I have vertical sketch axis, I have horizontal sketch axis, and I have an option now of sketch axis 0. In this case, it is the construction line I just sketched in the sketch here. So if I choose that option, we get the result we want to have. I click on OK, and that's it. The revolution is done like we wanted it to be. If we toggle the visibility of all the pads, we can see here. Now, if you couldn't remember what the distance of between this plane and this plane is, of course you could have a look in the sketch of this second pad we did here and see what dimension we applied here, but you also have a possibility in the part workbench, and with newer versions of FreeCAD you can apply these tools to other workbenches as well. You have a possibility to do measurement in 3D a little bit. You can use the measure tool here, which only measures between, generally speaking, 2 3D points. There is no possibility to select exactly an endpoint or to snap to a line or midpoint or something like that. You just measure from this point to this point in 3D space. So it's a little bit, well, it's not a that accurate measurement, but for first rough visualization, it is okay. You can delete these things, and you have here tools for better measurement. You have here a tool to measure linear or to measure angular, to measure angles. For instance, if you want to measure the distance between these two planes, you activate the measure linear tool, and now you must select two elements you want to have. The first selection is this plane here. I did selection 1 here, okay. And now selection 2. And here we go. 70 millimeter here, as you can see on screen, is displayed as a distance between these two planes. At the moment, this is everything there is in FreeCAD regarding measurement in 3D. You have not no tools to measure, for example, of a simple cylinder, its radius or its diameter directly, but you could do it with the drawing workbench and 2D view of a selected part. But you could also first I will clear this dimension here with clicking on here. And what I wanted to say is you could also have dimensioning tools within the draft workbench to use for measuring radius and things like that in 3D, which we will have a look at in a later lesson. So now we want to do the next step. We want to do a second revolution here. And so we will do just now this operation. So since we want to do a revolution identical now to this first revolution we just did, we will try to save some time and some energy, and so we will try to use the sketch we just did once more. So in FreeCAD you have a possibility to copy the sketch or something else to the clipboard and paste it in again to reuse it. But there is one limitation. In FreeCAD you can only copy 2 instances of a 3D operation to the clipboard, not more. If you would have something like let's say cut and revolution and sketch, something with several instances, only the last or to be more precise, the top 2 instances will be copied to the clipboard. I also experienced sometimes a little bit trouble when sketches are mapped to a face. If you try to copy them, sometimes the sketches will have some linkages to some geometry or whatever. What really works well if a basic sketch which you copy to the clipboard is linked to one of the basic planes and not to a face. And I personally prefer to copy sketches to the clipboard and not the revolution or pad to avoid some troubles. So we mark sketch 004 in this case, and we could do edit, duplicate selection, or edit copy to the clipboard. We click in 3D space to unselect everything, and we say edit, paste, and we have sketch 4 duplicated. So I toggle now the visibility of these 3D bodies, and I say edit sketch, and we want the sketch to be on this side of the axis and not this side. So I mark the construction line here and I delete it. And so I click on the line here and drag it around here. I draw once again a construction line. So I have to catch this axis here. Apply a horizontal constraint. Select the line, toggle construction mode. Apply a constraint of 20 millimeters. And then I have to apply a vertical distance of this point in regard to the origin of 70 millimeters. I close the sketch and I do once more revolution around sketch axis 0. I say OK. And here we are again. There may be occasions when you want to measure distances or angles in 3D to know how much you have to do placement on a 3D object in 3D space. So let's have a look at the measurement possibilities in FreeCAD at the moment. The first thing is the measure tool. It measures a distance of 2 points clicked in 3D space. There is no way of snapping to an endpoint or things like that. It is just an absolute measurement of a distance of 2 points in 3D space. You can highlight it and delete it if you like it not to be shown again. The next thing about measurement is, if we switch to part workbench, we have some tools here for measurement. It is a linear measurement or angular measurement between edges or planes. This is the next thing available in FreeCAD. So, for instance, to measure the distance between these 2 planes, I can mark the 2 planes here and select the tool Measure Linear. And the distance here is shown in this green font of 75 millimeters. I can clear all the distances shown and the angles shown, and I can also use the tool in just another way, that I first click on the tool and then do my selections. In this case, let's select this face. You see it is ticked now here, the selection with this green hook. And let's select this, and here we have 80 millimeters as absolute distance. We can toggle 3D mode, we can toggle deltas. Okay, in this case we don't have deltas because we have 2 parallel planes here. We can clear all and we can close, and we have angular measurement here. So if we want to know the radius of, for example, this arc here, we could either look in the sketch, or we could use the next thing available. We could switch to the draft workbench and use the dimensioning tool shown here. Since the dimension tool in the draft workbench is working also with snap modes and things like that, and you could use it to, for instance, get, when I try to say a snap mode to endpoints, to get an angular dimension from here to this point here. You see, we have an angular linear dimension of 50 millimeters. But since there are a lot of options with it, and with a release of 0.15 of FreeCAD, a lot of things with draft dimension tool have changed. We will cover that in a later lesson completely as a separate lesson for itself. So let's delete this here and continue with our modeling in 3D space. Okay, so let's switch back to the part design workbench, do a sketch on the YZ plane, and use a polyline tool to do a vertical line here, horizontal line here, do a slope upwards here, and go back to the origin. So let's apply a horizontal distance of 20 millimeters here, a vertical distance of 2.5 millimeters here, and the slope should get a vertical distance of 2.5 millimeters. So to get our sketch axis, we can sketch a line here. We apply a vertical constraint. We select the line once more, talking about construction mode. We apply a vertical distance to this line here of 14,5 millimeters, and we apply to the point here in regard to the origin a horizontal distance of 70 millimeters. We close the sketch. We make sure that the sketch 006 is marked, and we do our revolution around sketch axis 0. We say OK, and that's it. So now we have to do the same operation on this right hand side. So I select sketch, say duplicate selection, and we have sketch 7. We could toggle the visibility of the whole model to get a better view. We say edit sketch. We delete this constraint of 70 millimeter. We click on the point and keep the left mouse button clicked. We drag the point around here, and we apply once more a constraint from this point in regard to the origin, a horizontal distance of 70 millimeters. We apply revolution around sketch axis 0. We say OK. And now that's it. To get now to the third, let's call it a knob here, we have to duplicate this sketch 007. So we say edit duplicate selection. And now the problem is that the sketch is on the YZ plane, but we want it to be on the X on the XZ plane. So the thing we do is we toggle the visibility of a model here, and we mark the sketch. We change to the sketcher workbench, and there we have the possibility to say sketch, reorient sketch, to get the sketch mapped to a new plane. In this case, the XZ plane. We say OK, the sketch is opened and remapped, and we change this constraint to be 75 millimeters. We say OK. We change back to the part design workbench. We make sure that the sketch here is selected. We apply revolution. We switch to sketch axis 0 within the options. We toggle the visibility here. And as we can see, we now have the complete model here. So the next thing is to fuse all these separate bodies. So we switch to the part workbench. We select all the bodies here, and then we do make a fusion or a union of several shapes. We will click the icon and we will see the fusion went well. There is no exclamation mark, no problem. Everything is fine. So the next step is to punch the holes we need to through the model. So first we switch back to the part design workbench. We select this face here and we create a sketch on this face. First thing we do is we want to create dimensions and elements linked to external geometry. So we click on the icon here. We select one of these elements here. In this case, I select this inner circle to be able to refer to the center of this circle. So I now say I want to draw a circle. I will catch this point here and draw a circle, and then I will apply a radius constraint of 10 millimeters. I will close the sketch. I will make a pocket operation and choose through all as option. I click on OK, and here we go. The hole is punched correctly through the complete model. And so I will now say I will select this face. I will apply a sketch. I will take external geometry, in this case this circle, and with pocket you have the possibility to do several closed contours. Instead of one closed contour, you have to use, for example, for revolution. So I now created external geometry 3 times here, and so I will create now 3 circles with the center identically to the center of the referred faces, the circular faces here. So I will then also apply an equality constraint to all the 3 circles. And I will apply a radius constraint to one of the 3 circles of 10 millimeters once more. I will close the sketch. I will choose the pocket operation. I will say through all as options. I choose OK. And here we go. All the pockets are there, and the model is completed with the pockets. So let's go on now to the fillets we need. So when applying fillets or chamfers in part design to a 3D model, we basically have two options. We can choose either a face to apply fillets or chamfers to, or we can choose edges to apply the fillets. For example, if I choose this plane, this face here, and apply a fillet radius, you see every edge of the face I just chose will get this radius. But I can also choose or multi-select different edges. Let's select this edge. Now let's select this edge by pressing Ctrl. We do a multi-selection. As you can see, the multi-selection worked. These two edges are highlighted. And let's also select this inner edge. I press Ctrl now on Windows. And let's select this inner edge and apply a radius of 2,5 millimeters. And that's it. We just applied a fillet here. You can edit the fillet every time. The only thing which I'm missing a little bit is, at least in part design, I would like the fillets I just changed to be highlighted in the 3D view. But maybe this will be introduced with one of the next versions of FreeCAD. And well, with this operation we have reached the end of today's lesson. I hope you enjoyed watching the video, and well, have fun with FreeCAD and maybe see you in the next video. Bye!